All right, so we open a new tab this way. Let me share the screen again. All right, so I believe my screen should be visible now. Okay, my screen should be visible now to everyone. So what we are going to do on this new tab, what I'll do is I'll just to access Google Colab. I'll just go to Google. I can just do Google Colab and then hit enter. All right, so it will bring you to this point on your browser. So you can decide to go to welcome, but I'll just pick the first one, which is Google Colab. You just click on Google Colab. All right, you just click on Google Colab. Now once you've clicked on Google Colab, you should be arriving here. Okay, so once you've arrived here, then you can actually uh, explore this page. There are so many things you can do on Google Colab. All right, so they give you news. There's some sort of blog. You can actually go through notebooks that others have actually made available for public view. I'll tell you what a notebook is, and then you can track changes. Okay, you can find more resources to help you get certain things done. Okay, so Google Colab is a very robust and a very rich environment. Now you can let me tell you first what a notebook is. Okay, so initially what we did, we usually wrote our code in or on Visual Studio. So we'll create our Python files and then we'll get to execute them and then we get our response. But now what we are actually going to do, or what notebooks do for us, is some sort of environment that makes most of the processes that we would want to take, it automates it for us. Some sort of service, okay, that gives us access to resources and some pre-installed libraries that we'll have to use without having to go through the hassle or the stress of doing it manually, installing it manually, and then having to update it to get up to date with other dependencies or other things within our system that will cause it not to run properly. So that's basically what a notebook does for us. So you can create multiple notebooks, you can create many notebooks on this particular environment. Okay, so what we are going to do is, for me, I'll just click on open Colab. All right, so if you can still see my screen, you let me know. All right, okay, so okay, yes, you can still see my screen. That's good. Okay, so since you can still see my screen, let's uh let's continue. So at this point, this is where we are now. This is the welcome environment that we are on. So there are so many things you can do here. You can just click on examples and see different things that others have done. There are how you can generate charts, markdown guide, external data drive sheet and cloud storage, forms, and so many things. Okay, and then we have recent. So you find out recent things that you've actually done, recent notebooks that you've actually used here on Google Colab. So I have a few here, which I didn't really do much with it. Okay, so you can actually have something stored on your Google Drive, and then you can actually push it to Google Colab. So you have a file stored on Google Drive, but you can pull it from Google Colab and then execute it. Okay, then there's a platform we call GitHub. GitHub is a repository, or yeah, let's call it a repository, some sort of warehouse where we store code or programs, and then it tracks the changes that we make to the files within our code. Okay, that's what GitHub is. And then we have the upload. All right, so we could actually do an upload. All right, So what we are going to do first is we are going to create a new notebook. All right. So I believe we are still on the same page. If we are still on the same page, you let me know. If you have any question, you go ahead and then you ask so that uh, we can move forward. Any question? Okay, Jojo, I can see your hand. Yes, go ahead. Yes, I can hear you. Yes. Okay. When we open okay, when you open Google Colab, you see two things. It will give you two options: open Colab or new notebook. All right. So if you go through open Colab, then you get to the current page that we are on right now. Okay, but if you click on new notebook, that means you just want to go ahead and open a new notebook and then you can run code on that notebook. Okay, so the next step is to decide if you just want to go directly and run code, or you are going to make some changes to uh, you're going to make changes to your settings and all of those things. So you can now do open collab or you can do new notebook. So whichever one you choose, it will always get you to the same destination that you would intend to get to. All right, I hope that answers your question. All right, Jojo, I believe that answers your question. So let's continue. I believe we can still hear me and you can still see my screen. Okay, yeah. Yes, go ahead. Okay, so just hold on a little. Yes, you actually have to click on new notebook, but you just wait a while so that when I share my screen, you see what I do and then you can actually replicate it. Is that okay? All right, no problem. So, sir, I saw your hands raised. I don't know if you wanted to say something, sir. Yes, sir. So I can see your hands. I don't know if you want to say something. Okay. There's a question here from uh Tehila. Tehila is asking why we are using Google Colab. Okay, so Google Colab is an online environment that allows us to have access to what we call notebook, services that run on the cloud. All right. Now, if we are building very heavy uh, machine learning or artificial intelligence programs or projects, it takes a lot of system resources. Okay, it needs very high powered systems, what we'll call either we'll call them GPUs, okay, to run our programs. So most of the times our laptops does not have the power to carry most of those programs. Okay, like those really heavy ones, most of them our laptops cannot carry. So what Google Colab does for you, or what these notebook services on the cloud do for you, is they allow you to access their high powered mechanisms and systems on the cloud, and then you run your project or your code on their high powered systems that are on the cloud, rather than running those processes locally on your personal computer, because running it on your personal computer will take a lot of system resources, and at the end of the day it can actually damage some part of your system if you are running something that is really really heavy. Okay, but for light task, you can actually just go ahead and use your local system. But when you want to run something that is heavy and you do not have the capacity or the resources to buy those high powered systems that have GPUs and set them up, which definitely you don't, you will actually have to use these kind of environments. Example would be Google Colab. There's also Kaggle, but we are sticking to Google Colab because it's fun to use and it's very easy to navigate. Okay, so Tehila, that's why we are using Google Colab. I believe that answers your question. Now let's move over to uh, Google Colab, and then let's create a new notebook and let's do some very nice things with computer vision. Okay, so we will get to advance this project as we go. Okay, so if you are still with me and my screen is still visible, a thumbs up, and then I can proceed from there. All right, Tehila, thank you. Okay, so I can see thumbs up from Jojo too. I can see from Vincent. I can see from Aaron. Okay, so we are good to go. So let me continue. Let me get back to sharing my screen. So we have we have this environment. So I'll just click on new notebook. All right, I'll click on new notebook, and then the notebook will be loaded for us. Okay, so you can see we have this notebook at the moment. All right, so everybody can see this notebook. So this is what a notebook typically looks like. All right, that's basically what a notebook would look like. So we are going to write some code here, and then we are going to run it. Now, um, this environment is actually helping us to connect to, like I said, those high powered systems on the cloud and all of that. And then we can actually do some sort of AI based programs, and then we get our result. We are going to do something very very simple but very very catching and very nice within our programs. Okay, so we are going to build a face detection system. Okay, now face detection is different from face recognition. All right, so but for today's class we are just going to do face detection, so it's able to look at faces, and then it's able to tell you that okay, this is a face and this is not a face, or just basically you give it an image and then it will be able to detect faces on the image that you have given to it. Okay, so that's what we are going to do for today's class. So for us to begin, I would like to do this, so I'll just edit this and give it a name. I'll call it a face detection. All right, so that will be .ipynb, and that's it. Okay, so the first thing that I'm going to do now, I'll be explaining the code as I go. All right, so you just follow up, and then I'll use comments as well while I'm typing my code so that you can see, and then you can actually. Oh, okay, okay, all right, so let's see how this gets bigger. I think at this point we are okay, right? I believe it's much more visible uh for for you, right? I've actually increased the size. I've zoomed into the page, so I think you should be able to see that much more better right now. So That's as far as we can go. All right, so here we are. I believe everyone can see my screen and it's not too tiny. Please, if you can see my screen and it's okay, just let me know so that we can fix that up. Okay, good. So that means it's much more, like it's bigger, so you can see much better. Fine. So let's get back to what we wanted to do. So the first thing that I'm going to do, I'm going to bring in something. Now, in our last class, which was yesterday, we talked about importing functions and modules and libraries and all of that. Okay. And we were able to write our own functions, and we were also able to import them and use them. And I had said in the last class that you do not really have to invent everything, from scratch. You don't have to reinvent the wheel every time you're writing code, because other people will write and they will look functions and packages that you can actually import and use. Now, there is a very important uh, there's a very important library that we will have to use when it has to do with anything that involves face recognition, face detection, and anything that has to do with face or computer vision. Okay, so that library is called OpenCV. Anything you want to do that has to do with computer vision, then you're going to have to use OpenCV. All right, so for us to use OpenCV, we don't need to start writing our own computer vision library from scratch. Whatever OpenCV has done, we can actually use it, and then it will help us, make our programs really nice. So let's start by writing the first line, which is going to be to bring OpenCV into our application, which is to install it. So I'm going to install OpenCV, and this is how we do it. Okay. So I'll be commenting as I go. So I'll do this. I'll say install open CV. Okay, so how do we do this? I'll do pip install open CV. All right, now looking at this, you may want to ask, what is pip, right? So let me explain what pip does. Pip is a Python installation package, all right, or Python installer package. So what it does is it helps you to install libraries, modules, or to pull resources that you need and actually put them into your program. Okay, so it's a kind of installation package manager. So it manages installation, it manages the installation of packages and libraries and all of those things that you actually want to get into your program and use them. Okay, so with this line, we are actually installing OpenCV in our program. Okay, so we install OpenCV. All right, so let me write it properly so that we can actually get it. So sorry, OpenCV, and I'm going to say Python. Let me just specify. All right, so the next thing we are going to do, I'll be writing comments as we go. Please, please, can you turn off your microphone, please? All right, so let's actually get to import the libraries and use them, because we've actually done. Someone's microphone is still turned on, and that's really distracting for us. Please turn off your microphone if you are the person. Okay, so let's move forward. Good. So I'll just say something like import the libraries. Okay, so I'll say import the libraries that we are actually going to use. So let me go straight to this. I'm going to say import libraries. You can remember this from our last class. So I'm going to say import. Uh, I'm going to say CV2. That's the version 2 of the OpenCV. That's what I want to use. I'm also going to import uh, I'm going to import matplotlib. Okay, now matplotlib is a library that helps us to also visualize and then actually get to plot um, images, and then actually get to show them on our screen. So I'm going to import matplotlib into the program so that we can actually get to use it. So this is how we import matplotlib. So I'm going to say import matplotlib dot pyplot as plt. So now in the last class I told you that we can actually import packages, and then we can give them an alias so that we don't have to type long names all the time. And now you've seen that we actually have something like that here in real implementation. Okay, so that's what we do. I'll do a few more imports, and then we get to continue from there. All right, so let me get from google.colab import. So I want to use their file properties. Okay. All right, so we are good to go. So we import files. All right, so now this is the first step that we are going to take in order for us to get this application running. So I'm explaining the code one after the other. I don't just want to rush and write it. So uh, I want to take it step by step. So we are going to upload a certain image from our computer. So that's what we are going to do. And then we will detect the faces that are actually on that image. All right. So let's go ahead and I'll say this upload files from computer. Okay. So what I'm going to do, this is how you do it. So I'm going to say upload uh, equal to files dot upload. All right, so let me change that so that it does not conflict. So I'll say uploaded file equals to files dot upload. Now this will help us to actually upload a file from our local system onto the program so that we can actually detect the faces in that particular program. All right, so let's get to continue. I'm going to get the image into I'm going to load the image into a list and then pass it to my open CV so that I can actually read the image, and then we can do a few more things with it. So we are taking it step by step. So we are loading the uploaded image right now. So I'm going to get the path of the image. So I'll say something like image path equal to, so it's going to be list. Um, all right, this is going to be a little, it's going to be a little technical. So I'll just have to be careful with the typing. So we have uploaded, so list, we now have uploaded uh, file. All right, so we have uploaded file dot keys. So uploaded file dot keys, and then here we can actually do 0 here, and I think that should actually fix that for us. So what we have done here, let me comment this, is add the uploaded file to CV. All right, so since we are still here, let's continue, and then let's have it read the files for us. So I'll take image. Let me get something else. So I'll say image equal to, so we use the CV. Now remember, we actually imported this open CV, so we can actually use it to do a lot of things. So for now it may not really make sense, but as we keep going, I'm going to explain them one after the other, and then you see what actually happens there. All right, so CV2 dot im read, and then I'm going to say image path. All right, so we do that. Then the next thing we are going to do now is we are going to convert our image to a grayscale. Now, if I should ask, what is a grayscale image? If anybody has an idea about that, what's a grayscale image? Anybody? I asked, what do we mean by grayscale? When we say an image is in grayscale, what does it mean? Okay, seems nobody really has an answer for that. So when we say an image is in grayscale, it means it's in that state where it is not uh, colored. All right, so it's black and white. Okay. uh okay, Aaron says it's not at full resolution. Not really. What it entails is that the image is not colored. That's the first thing. There's no color in the image, so it could be black or white, and then it could actually be some sort of, well, when we say grayscale in images, we are really talking about something that is very, very close to being black and white. Okay, so now computers will not use your regular color to detect faces or run images. They actually work with the pixels of the images, so they focus more on having the images not to be colored. All right, so computer will love to have the images to be in grayscale. Okay, so that's why we are converting the image to a grayscale image, so that it can actually go through it and then give us what we are looking for. All right, so let's continue from there. So I'm going to convert that image to a grayscale image. All right, so to do that, I'm going to show you how it's being done. All right, so let me write the code for that. So we now, let me just comment it, convert the image to grayscale. So we can now say gray image equal to cv2 dot, I'm going to use a function now. We call the function cvt, and then within the CVT we are going to pass in the image that we want it to convert into grayscale. So the image now happens to be this image that we read into CV. So CV is able to see this as an image, and then we can pass it. So to do that, we just pass in image here, and then we want it to be grayscale. So we say CV2 dot color, and then the color is going to be BGR to gray. All right, so that's how it's being written. Sorry, BGR to gray. All right, so this line of code actually will take that image and convert it into a grayscale image. That's what it does. All right, that's basically what it does. So what we are going to do next, um, I want to take this step by step. Okay, so let's we can decide to display the grayscale images, but let's just go into detecting the faces. All right, so let's go ahead and uh, write some more code. All right, so I thought someone raised a hand, so let's continue. So what I'm going to continue with is to actually detect the faces. So let's say detect the faces in the image. All right, so this is what we are going to do. I'm going to say face cascade equal to, so I'm going to use some functions here to actually detect faces. So look at this code very, very closely. All right, so what we are going to do is I'm going to say cv2, which is the library that we are using. So cv2 dot, we now say cascade classifier, and then we say cv2 dot, it seems that I've done this here before, so it just gives me uh, it just gives me yes, it just gives me the code because I've written it here before on Google Colab. So we do hack cascades. We now make we now get the hack cascade, and then we pass in the type of hack cascade that we want it to use. I'll explain that in a while. So this is going to be hack cascades frontal face, because we are looking at the frontal face, not the side, not the back or whatever. So we are looking at faces. So whatever model was trained, okay, to recognize faces by OpenCV is stored inside the hack cascade frontal face file. Okay, so let me just write it out, and then we can so hack cascades frontal face default dot xml. All right, so I have to reduce this so that you can see the full code. Good. So having done that, this model will detect the faces that we have in the image. All right, so we can do more just to make our program very, very nice. Now, what we are going to do is when the face is detected, we are going to, draw rectangles over the faces to detect that, okay, this place that you are seeing, this object that we are seeing, this is a face and this is not a face. Okay, so something like that. So let's go ahead. Before we do that, let me just do one more thing, and then we are going to detect the faces in the present image that we are going to use. Okay, so let me do from pre-trained model to differentiate that. So I can now say detect, sorry, I can now say detect faces in the current image. All right, so I'm going to say faces equal to, so I'll say face cascade dot detect multiple multi-scale, not multiple, sorry, multi-scale. So we are going to use a gray, what is it called? The multi-scale will take in gray uh, image, all right? So we'll now say gray image, which we have actually defined. So we define the image here. So we take gray image here. Let me just copy this, and then I paste it here. All right, I do a comma. Now there are other arguments, or there are other parameters that I have to pass in this particular line. Okay, so the scale factor of the image, the minimum number of neighbors, and so many things. That's a whole lot, and it's really mouth watering, but I'll try as much as possible to explain them. Okay, so I'll pass in the scale factor, and it's going to be equal to 1.1. So I'll use 1.1 for that. So 1.1. I'm going to pass in the minimum number of neighbors. All right, pass in the minimum number of neighbors, and I'll use 5 and then the minimum size. All right. So minimum number of neighbors, I'll use this to be 5, and then I'll say mean size, and that's going to be 30. I could just say, let me just say 40 by 40. Okay. So having done that, let's go ahead and do the real exciting part. So let's do draw rectangles on detected faces. So here we go. So we are going to write a for loop. In one of our classes, we actually worked with a for loop, and then I believe that you know what it is. You know that a for loop or a loop generally repeats a particular statement until a particular condition is met and all of that. So we are actually going to use a for loop and then go through the image, and then we now draw rectangles over any face that has been detected in the image that we are going to pass. Okay, so let's go ahead and draw the rectangles around the faces. So I'll say for I'll do this x comma y comma w comma, and then we close this in faces. All right, so we actually excuse me, in faces. So the faces that are detected, we can now draw over them. So that means there could be multiple faces. So we now actually use faces this way. And then we now use the CV class again. And it has a function called rectangle. Sorry. Um, okay, I thought someone raised their hand. Okay, nobody raised their hand. Let's continue. All right, so we do rectangle because we want to draw a rectangle around the the face. So what we can now do is we now pass in the image. All right. So I'm going to pass in the image. So we say image, and then we pass in some coordinates. We want x and y, and then we are going to pass in another set, which is going to be x plus y, and then we're going to take uh, y plus h. All right, so one last thing in that particular function. So we are going to do this 0 comma 255 comma, and that's going to be okay. I'll use 25500 and then 2, not 0255. So let's do it this way: 255 comma 0 comma 0, and then we are going to now do comma 2. Okay, so that has been done, and then we can now display it on the screen. So we already have this. I think I've run this before here, so it's just doing auto suggestions for me, and that's very, very nice. So we'll display the images and the faces detected, and for us to do that, we're going to use our matplotlib library to do that. So we say plt dot image show, so because we want to show an image. So what image are we passing and what are we using to pass it? So cv2 dot cvt, and we want it in the color now. Okay, so when we wanted to detect the faces, we changed it to grayscale, and um, now that we actually want to put it out, we want to put it out with the color. All right, so we are bringing it back to the proper color that was there before. So I'll put in change it to let's just say bgr rgb. That should do it for us. So this is going to be cv2 underscore bgr2 rgb. I believe that solves our problem. Okay, I missed out on something. Sorry, this is dot, and that should solve the problem for us. And then I can actually visualize the data, and then print, just plot the image. Okay, so let's go ahead and just do that slowly. uh, so I'll do plt dot figure, and then what we are going to do is we are going to set the figure size. So I'll say fixed size. We'll just keep it at, let me make it a little bigger, so 15. What is it going to do again? plt not show. I need to add something to it. Let's remove the axis from it. Okay, so I'll just do im show first, and then add axis to it, and then I can continue. All right, so im show, and then I'm going to pass in the image with the rgb. I didn't have that image with rgb, so image with the rgb, to return it to rgb. So we don't want any axis. I'll explain what that does. Okay, so I'll turn off the axis, and then I can undo plt dot show. All right, so image rgb, I think I didn't get that, so let me actually put that. Yeah, so I should have converted this directly and just forget about coming through with a lot of stress. So let me just change this. This is not supposed to be here. So let's do image equal to, so let's do it this way, cv2 dot cvt color image, and then we now do cv2 dot bgr2 rgb. So that should solve our problem. Now that's a whole lot, and then I understand that at the moment everyone is thinking, sir, what are you really doing? Okay, so let's actually get to run this, and then I'll explain it again, and then you understand it better. How about that? Are we still together? Vincent, can you see my screen? Okay, all right. I think others have exited the class. I don't know what happened, but let's just finish up. I'll explain everything, and then they will have to look into the video and then follow up on what we have done. So you're going to see the output of what we have done so far. So this is what I'm going to do. I have a picture already within my, so what I'm going to do is, okay. So what I'm going to do is I'm going to uh upload an image. All right, so let's get to run this program that we've just written. Okay, so once I click on run cell, okay, once I click on this, let me reduce this so that you can actually see some things. So I'll click on run cell, and then it will run this code. So when you want to run, you have this play button by the left. Okay, you can always go to, you can also always go to, there's another place that you can actually get to click and then you run, but for now we deal with run cell. Okay, so if I click on run cell, this should actually be what we will see. So underneath where we have the code, you will see this is actually loading and is running. Okay, so we have a problem here. It says face is equals to face cascade dot detect multi-scale gray. Okay, positional argument follows keyword argument. Okay, so there's something that I missed out, so let me go back and correct it. That's it. Okay, so grayscale image scale factor, mean neighbors equal to 5, mean size is 40/40. What did I miss? All right, let me look at that line closely. Grayscale or gray image, detect multi-scale. So I think I don't know what the problem is. So let me actually just um, let me look at this and let's see what happens. Um, just a minute and then we are good to go. So mean size, let me change this to 30/30. I use 30/30, so let me use 40/40 again, and then let me see what happens. All right, so let me run this again, and hopefully there will be no errors this time. So just underneath here, okay, requirement already satisfied. Now you can see it asks us um, to choose files. Okay, so we can actually upload multiple files, but I have just one file that I've already downloaded. It has multiple faces. It's like many people in the same place with their faces showing. So this should be able to detect the faces in the picture. Okay, so let's go ahead. I'd like to upload that specific uh okay, let me start off by detecting one single face. All right, so what I'm going to do is I'll do this. I'll choose one file. So let me, I have some images of the guy who plays Batman. So let me do this. So while this is going on, I'll just open this archive data train and then Ben Affleck. So I think I'll use this. Yeah, so I'll use this image. So I'll open this up and then it loads the image, it saves it, and then it gives me an error. Okay, there's an error in line 13. So let's go back to line 13 and fix this error too. Okay, let me fix that error, and then I can actually get to I'll just paste this in. I have working code. So let me change this again. Let me just use what I used the first time when I worked on this. So this should actually work. So let's run it again and hopefully there should be no errors. Okay, so it's still coming up. So while it's loading, we have to wait. That's because internet also has a role to play when it has to do with working with notebooks. So let's go ahead and choose files. I'll choose the same file again. I'll click on open and then let's see if we have any error. So we have another error on line 17, gray image equal to cv2.cvt gray image. So let's go back to that line and fix it. Okay, so I use cvt instead of cvt color. Sorry about that. So that should solve our problem. We run it again and then choose files. I'll choose the same file again and now open. So let's see what happens. All right, so we have another error on draw rectangles on detected faces, detect multi-scale. Okay, so we have let me look at the lines again. Line, okay, face detected, uh detect multi-scale. All right, so detect multi-scale. Let me keep this at the default that I've actually used before. Let me use a working copy. All right, so let's try this again. All right, so let's try this particular time. I hope we don't face any problems again. So we keep having a particular problem. Um, okay, so let me actually try another image. All right, so let's rerun this. I'll try another image that I have on my. Let's use an image that has multiple faces. So let's say what is it called? Mm, let's just find. I think I have an image with multiple people. Let me look up for an image that has multiple faces. All right, so let me just choose this one and then get to use it. So okay, so something like this. Let me open this up. Then I think I used this one time and it was very okay. But right now we're having some errors. Okay, so OpenCV detect multi-scale. So it says empty function in detect multi-scale. All right, so there's something that I'm missing there. Okay, so I'm going to do something one last time and then, all right, let me refactor the code, run it again, and then we see what happens. All right. Okay, yes, I can hear you, Jojo.
Okay.
Now, when we say debugging is basically you looking into the code and then finding out what the problem could be and then trying to fix it. All right. So fine. Okay. So this works. All right. So now, if you can see this, we have this image with multiple people in it, and then we are able to see the program is able to see faces, recognize faces, and then detect that okay, these are faces. Almost similar to what you have when you are. I don't know if you've used some of these um, um, what are they called? Photo apps. And then when there are multiple people or AI based, yes, you have some AI based cameras that when you actually want to take photos, what it does is it actually detects the faces in the picture. As many as they would be, it will actually highlight those faces and then draw the boxes around those faces to show that okay, this is a face, this is a face, this is a face, and this is a face. Okay, so that's what we have done. Let's try it now with some other file. I'll run this again. Let me see what happens. Let's use another image that has probably a single face, and let's see how well it will fare. So let me still use this file that I wanted to use initially and see if it will still detect the face. It runs and then it basically does not detect the face because this image um, kind of looks blurry. No, it does not just work for multiple faces. It works for a face generally, but there needs to be some sort of it needs to be frontal. So fine. So you see, this is a single face, and then it's still able to detect the face. Not so it does not just work for multiple faces. It works for even a single face. So it's able to get to know that okay, this is the face, and from this we can further build. From this we can further build uh, we can further build things that we can actually build things that recognize faces and then tells you that okay, this is John and this is Peter and this is Paul. All right, this is Grace. So we can actually build something like that, but it starts first from being able to detect the faces within the picture or within the photo. All right, so when that has been done, we can actually detect the faces and then we can further start to recognize them. Okay, so for today's class, we have just dealt with this face detection. We are actually dealing with we have dealt with face detection, and I will not want to overload. So in the next class we are going to have to stretch a little, and what we are going to do is we are going to do face recognition. So we detect the faces and then we recognize who is this and who is this. So we'll be able to detect multiple people. So in the next class, what we are going to do, we are going to build a project that um, we will bring up the image of people, and then to be able to tell us, okay, this is John, this is Janet, and this is Ricky. Okay, so that's what we are going to do in the next class. Still to tidy up on our computer vision. So far, I know that this has been really, really much. So what I'd like us to do now is to ask questions. I see how I can actually answer them, and then we can, look into calling the class a day. So if you have questions, as usual, raise your hands and then you can actually ask your questions.